Hello everyone, I welcome you all for today's session. So in today's session we'll be taking up a numerical on Mohr circle. We have already solved a numerical on Mohr circle in the previous video, so this is our second problem. Right, so let us start with today's video lecture. A machine component is subjected to the stresses as shown in the figure. Find the normal stress and shear stress on plane AB inclined at an angle of 60 degree with x-axis. Also find the resultant stress on the section by Mohr circle. Right, so this is the statement given to us and this is the relevant diagram. Okay, if I just check it out, he has given the state of complex stress because it is having plane stresses as well as shear stresses. Right, now he has given an section or a plane AB. So this line what you are observing in brown color, so this is section or plane AB which is making an angle of 60 degree with respect to x-axis, right, which is making 60 degree with respect to x-axis. Right, now you may think x-axis is here, how I am calling this as x-axis, right? So any two lines which are parallel, right, their angles will also be similar because it becomes corresponding angles in that case, right? So it is this line or this face is parallel to x-axis, so this angle is 60 degree. Now I have been asked to find out the normal stresses and shear stress on plane AB, that is on the oblique plane, right? And next I have been asked to find out the resultant stress on the section AB, right? So let us start with today's problem. Let me first note down the given things along with their sign conventions. So in order to do that, I need to fix the reference plane, right? So without fixing the reference plane, it is very difficult to proceed, right? So first, let me fix the reference plane. Okay, always keep in mind, if this diagram is not given and if he has just given you some statement, you need to take the maximum stress value as x-axis, because in our analytical as well as in our Mohr circle we always assume that sigma x is greater than sigma y, right? So whenever a statement is given and you have been asked to draw the state of stress and then continue with the Mohr circle, always keep in mind whichever is the highest magnitude that you take it as sigma x and whichever is the least magnitude that you take it as sigma y, right? So in this case there is no problem because sigma x is along x direction only and it is of highest magnitude and sigma y is 50 MPa, right? Now first I need to fix my reference plane, so let me fix the reference plane. So reference plane, I'll take this vertical plane as my reference plane. I'll take this vertical plane as my reference plane, right? So this plane I'll take this plane as a reference plane, right? Okay, I'll take this blue colored plane as a reference plane. Now we are in need of an angle theta which is with respect to reference plane, right? So with respect to reference plane, how we are going to find theta? It is very simple. So this face and this face both are 90 degrees, right? So 90 minus 60, total angle here is 90. Total angle between this blue line and this line, total is 90 degree, whereas this is 60. So what is the remaining angle? So remaining angle will be 30 degrees, right? Because we know that 60 plus 30 makes a sum of 90 and 90 is the angle between these two mutually perpendicular faces, right? So this is the start point. Once if you fix the reference plane, next let us note down the magnitudes with respect to the reference plane. What are the magnitudes of the stresses and what is the magnitude of the angle, right? So let me start with the solution part. Okay. So I'll write here as solution part, right? So I have already fixed the reference plane. Now let me write the given things along with their sign conventions. So sigma x is 100 MPa. Sigma x is 100 MPa with a negative sign. Why negative sign? Because it is compressive in nature. Similarly, sigma y is minus 50 MPa. Minus 50 MPa. Reason, it is once again compressive in nature. Right? Then I go for tau xy. Tau xy. So, with respect to this reference plane, which is blue colored line, you just check out the direction of this shear stress. Just check out the direction of this shear stress. Right? Direction of this shear stress with respect to this. So, it is trying to rotate this reference plane in anti-clockwise direction. Right? It is trying to rotate the reference plane in anti-clockwise direction. So when it is anti-clockwise, once again shear stress is also negative, 25 MPa with a negative sign. Right? And theta, okay, when you get this theta, you can just check it. Whenever your vertical plane is like this, right? Your vertical plane is like this. And if you want to go to the position of the oblique plane, I need to rotate it like this. Right? Initially I was here. Now if I want to go to the position of the oblique plane, I need to rotate it like this. By what angle? By angle of 30 degrees. Now what kind of rotation is this? What kind of rotation is this? Just check it out. Is it clockwise or anti-clockwise? Right? So this is anti-clockwise movement, and that is the reason theta is also negative. Right, so this is the given data along with their sign conventions. You please note it down because sign conventions are important. Right, sign conventions are important. Now let us draw the Mohr circle. So to draw the Mohr circle, as I already discussed with you people in the previous video, we need to assume an scale. Right? So to assume a scale, first we need to note down the values of maximum stress. Then along with their signs, I am going to decide how to draw Mohr circle. Right? So without wasting much of the time, let us proceed to draw Mohr circle. Okay, first let us assume the relevant scale. So to assume the scale, I need to look the magnitudes of stresses. So it is 100 MPa, 50 MPa and 25 MPa. Right, so I'll assume the scale as, I will assume the scale as maximum value is 100 MPa. So I'll assume it as 1 mm is equal to 1 MPa. 1 mm is equal to 1 MPa. So maximum value is 100 MPa, that is 100 mm. Right? Now let us start with the drawing of Mohr circle. In order to draw that, since I know that both the values of sigma x and sigma y, both the values of sigma x and sigma y are negative, so majority of the Mohr circle comes on the negative side. Majority of the Mohr circle comes on the negative side. So let me check out. So I'll take it somewhere over here. Okay, so this is your y-axis in normal terms, and if you want to speak in terms of Mohr circle, so this axis is shear stress axis. So this is tau axis, right, according to Mohr circle. Then I need to draw a horizontal line. So let me draw a horizontal line Okay, so that becomes your horizontal line. So what does horizontal line represent? Horizontal line simply represents which axis? Sigma n, right? So this is sigma n axis, which is the normal x-axis. Now first let us start with plotting of the points. In order to plot the points, we need to know two coordinates or coordinates of 2 points, right? Only then I will be able to draw the line, allocate the center of the Mohr circle, and then draw the circle. So in order to draw those 2 points or locate those 2 points, I need to know the coordinates. Right? So let us check out what are the coordinates. So here once again I'll come back to this diagram, and if I just check out, okay, now this is my vertical plane, so I'm wholly concerned with this triangle only, right? Because this triangle gives me 2 faces. One is this face, which I call it as face B or plane B, and one is this face, which is horizontal. So this I call it as plane A, right? This I call it as plane B, right? So the coordinates, I'll just mark it here for this particular face, for this particular vertical face. So you can call it as point B. The coordinates are -100, -100 because it is compressive, and this is -25. What is the reason? Because with respect to this reference plane, shear stress is in anti-clockwise direction. That is the reason it is -25. Similarly, now I take it on this face. Right, so what are the coordinates here? Once again -50 because it is compressive. What kind of moment this shear stress is making with respect to this reference plane? I repeat, what kind of direction this shear stress is making with respect to the reference plane? It is clockwise, right? When it is clockwise, so it is positive. When it is clockwise, it is positive, right? So we got 2 coordinates, one for point A and one for point B. So now with these coordinates, let us get back to our graph sheet and go for plotting of the Mohr circle. Okay, so first let us allocate point A, or you can say state of stress at point A. The coordinates are -50 and 25. -50 and 25. Right, so when I say -50 from the origin, so this is my origin, this is origin point, I'll take it as point O. Right, I want how much? -50, right? So if I want to allocate -50, let me take a transparent scale. So -50, right? So this gives me a value -50. So it is 5 centimeters. So 5 centimeters is 50 mm, right? 50 mm, and the stress given to me is 50 MPa. So this point gives me -50, and there is a positive coordinate of +25 from this. So +25 from this is coming at this point. It's coming at this point, right? So I'll just mark that point with red ink. So this is the point which is required. Okay, I'll call it as A. Right? Now the coordinates of this point are -50, -50, 25. Similarly, let us allocate the second point whose coordinates are -100 and 25. -100 and -25. Right? So when I say -100, I need to take 10 centimeters. Right? So I will be first marking -100 on sigma n axis. So -100 here comes out to be at this point, right? Now from there I need to take minus 25. From there I need to take minus 25. So when I say minus 25, it comes below, right? So it is how much? 10 mm, 20 mm, 25 mm, somewhere over here, right? So once again I'll take the reading and mark this point, right? So this point, the coordinates are B minus 100 comma minus 25, right? So these are the coordinates. So once if this is done correctly, thereafter you need to join A and B. You know the procedure, we need to join A and B. So I'll join A and B, right? So once if I join A and B, the line AB intersects sigma n axis at a particular point, and that particular point I call it as the center of Mohr circle. Center of Mohr circle. So this particular point I call it as center. This particular point I call it as center of Mohr circle, so I'll denote it as C, right? So once if this is done, I need to draw a circle. Taking CB or AC as radius. CB or AC as radius. So let me check out. Okay, perfect. Right? So if you draw things correctly, obviously everything falls in its place, right? But be careful when you take the scales. Please don't go wrong, because entire thing depends upon what scale you assume, right? Now once if you draw this circle is called as Mohr circle. Now you know what is to be done next. We are going to draw the perpendiculars, right? From this point I'll drop a perpendicular here, and from this point I'll drop a perpendicular here, right? So this I'll call it as, so this is A, B, C, then I need to take it as, this is as point D, and this as point E, right? Now once if this is done, let us go for calculating of maximum shear stress, that is principal shear stresses, sigma 1 and sigma 2, calculation of maximum shear stress, that is tau max. Then let us calculate the resultant, then we will go for calculation of angles. Right, now before we could do all those things, first thing what we will be doing is, let us allocate that section or the oblique plane, right? That oblique plane AB, first let us allocate that. Now in order to allocate that oblique plane, once again I need to refer back my original diagram and decide from which direction I need to start and which is my reference plane in this A and B, right? So let us go to the original figure and come back for drawing the Mohr circle. Okay, if you just have a look at this figure, we'll get to know that this B, plane B, which is vertical, this I will take it as my reference plane, and from the reference plane I am having this oblique plane at an angle of 30 degrees in anti-clockwise direction, right? B is the reference plane. From plane B, the oblique plane is at an angle of 30 degrees in anti-clockwise direction. Okay, coming back to Mohr circle. So B is my reference plane. From B I need to go in counterclockwise direction or anti-clockwise direction in order to locate that oblique plane, right? So I'll just keep it here at this particular point. Okay, so after keeping it here, in this direction it goes clockwise, but I need it in anti-clockwise direction, so I need to rotate my protractor. So this is important. Please trace things correctly, right? Okay, So from plane B I need to move in anti-clockwise direction for an angle of 2 theta degrees. So theta is 30 degrees. So 2 theta should be 60 degrees. 2 theta should be 60 degrees. So I'll mark here 60 degrees. Right. So that becomes my reference plane. So in order to avoid confusion, I will be using the same colored ink what I had used in the state of stress given in the problem. Right. So this is point, let us call this as, so you are having A, B, C, D, E. I'll call this as point EF. Right, so point EF is nothing but the oblique plane given to us in the problem, and it is making an angle of 2 theta degrees. Right, so this is my reference plane. So this angle is in anti-clockwise direction and it is 2 theta. 2 theta. Always remember this. Please don't mark it as 30 degrees. You need to go 60 degrees because all the angles which are coming at the center of the Mohr circle will be 2 times. Right? So we have already discussed that. So you got this plane F, oblique plane, and I am going to show it as F. Right? Now once if you are done with this, first let us allocate maximum and minimum shear stresses, then we will proceed further. In order to allocate maximum and minimum shear stresses, you need to drop a perpendicular from the highest point on the circle to the center. Perpendicular from the highest point on the circle to the center. Right? Now I have drawn the dotted line because even this is the highest point on the circle and even this is the highest point on the circle. So I'll just mark it onto the left hand side. I'll take the projection on the left hand side. So if I just take that projection here on both positive and negative side, so let me check out what values I'll be getting here. Right? Okay, so these stresses which are acting here, these stresses which are acting here in this direction. Okay, so this becomes tau max. Why tau max? Because here value of shear stress is positive, so this becomes tau minimum. Right, tau max and tau minimum, I have marked it. Right, what I have done, I have just taken these points, this highest point, and I have projected it onto the y-axis. Right, now once if that is done, let us go for marking of principal stresses. Now what is a principal stress? It is a stress which is acting on a principal plane. What is a principal plane? It is a plane on which shear stress is 0. So on this circle you just check out which are the points where shear stress is 0. Right? So this is one point where shear stress is 0, and this is second point where shear stress is 0. Right? So these are the 2 points on the circles where the shear stresses are 0. Right? So let us mark the principal stresses. So this point, if you just consider this, right, as well as this point, just drop a perpendicular from this. Right, now this distance is important for us. Right, so these 2 distances are important. From this point this distance, from this point this distance. Now let us decide which is sigma 1 and which is sigma 2. Now that becomes very important when it comes to this particular point. Why? I told you we need to purely consider the magnitudes only. So from point O, which is having the greatest magnitude or the largest magnitude, so this is the distance which is largest or greatest magnitude, right? So that is the reason this becomes sigma 1, which is major principal stress, and this becomes sigma 2, which is minor principal stress, right? So it is F. This point I'll take it as point number G. This I'll take it as point number H. Right? Fine. I am done with sigma 1, sigma 2. I am done with tau max, tau min. Right? Now let us find out sigma n and tau on this oblique plane. So in order to find the sigma n and tau on this oblique plane, what I'll do is I need to drop a perpendicular from point F. I need to drop a perpendicular from point F such that it goes and reaches sigma n axis. Goes and reaches sigma n axis. So let me draw a perpendicular here. Right? So from this point F, I have dropped a perpendicular here up to this point. Right? Now let me check out what is the value of tau and what is the value of sigma n. So if I just project it upwards, if I just project this line upwards, so this distance gives me value of sigma n, this distance gives me value of sigma n on this shear stress plane. Value of sigma n on this shear stress plane. Right? So if I just check out, let me check out what will be this value. I will just write it as sigma n. Later we will measure it. So this is sigma n on oblique plane. Sigma n on oblique plane. Right? Now shear stress. So once again I will draw the shear stress over here on this side. Right? Shear stress from point F. I am going to mark it here. Right? So this distance I call it as tau. Right? Tau is shear stress on an oblique plane. Sigma n is normal stress on an oblique plane. Right? So now we have located everything. Now at last let us locate some angles. Okay, in order to locate the angle, we always know that we are going to make use of the reference plane. So first let us locate the angles of maximum and minimum principal stresses. Right? Now, so from plane B, because plane B is my reference plane, so which is my maximum principal stress? Sigma 1. So H is the maximum principal plane. So this angle I call it as 2 theta P1. 2 theta P1, and I have also shown the direction. Right? Now I need to draw one more orientation. I need to locate one more orientation, that is for sigma 2. So sigma 2 lies here at this point. So let me show the angle from reference plane. So this angle is 2 theta P2. 2 theta P2. Okay, after locating two principal planes, let us locate shear stress planes. So I know that this value is tau max. This value we are having GH. I'll call it as I. I'll call it as J. So these two planes are for maximum and minimum shear stresses. So from the reference plane, this angle is 2 theta S1. 2 theta S1, maximum shear stress plane angle, and this value is this value in this direction is 2 theta s2, 2 theta s2, right? So you go step by step and mark the angles correctly. That is the best way to avoid mistakes, right? Go slow and mark things correctly. Now once if everything is done, let us proceed and calculate things and find out what are the values, right? So now we'll go for the calculation part. So now let us measure sigma 1 and sigma 2, right? So sigma 1 is coming out to be let me check out what is the value of sigma 1. So it is 11.2 centimeters or 112 mm. 11.2 centimeters or 112 mm. 11.2 centimeters, that is how we remember it. Next, let me check out the value of sigma 2. So value of sigma 2 is 40. So 11.2 and 40 are the two values which I am required. Okay, we know that scale is 1 mm is equal to 1 MPa. Okay, we know about this scale. Now from our measurement we got that sigma 1 is 11.2 centimeter, which is 112 mm. So therefore sigma 1 is equal to 112 MPa. 112 MPa. Similarly, sigma 2 I'll write here as compressive, or you can write it as negative. Both are same, right? Sigma 2 is 4 centimeters, that is 40 mm. So therefore sigma 2 is also 40 MPa. We can write it as compressive. Okay, I am writing it as compressive. In few textbooks they are not going to write it as compressive. They will put a negative sign. Both are one and same, right? So once if we are done with the magnitudes of principal stresses, then we will go for location of principal stresses. Okay, so let us locate 2 theta p1 and 2 theta p2, right? So 2 theta p1 okay, 2 theta p1, that angle is 46 degrees anti-clockwise, 46 degrees anti-clockwise, and 2 theta p2, 2 theta p1 is 46 degrees clockwise, this is this direction, and 2 theta p2 is 2 theta p2. 2 theta p2 is 134 and 46, 134 and 46, right? 134 and 46. So 2 theta p1 is giving me how much? 46 degrees, right? I'll take this as negative. Because it is I'll take 2 theta p1 as 46 degrees. You can take this as positive because it is in clockwise direction, clockwise with respect to reference plane, and 2 theta p2 I'll take it as minus 136 degrees, minus 136 degrees minus 136 degrees because it is making an anti-clockwise direction with respect to reference plane. With respect to reference plane, it is making sorry, pardon me, 136 degrees. So that is the reason it is negative sign, right? So therefore theta p1 is equal to 23 degrees, 50% of this, and theta p2 will be equal to how much? 68 degrees with a negative sign, right? That is the orientation of the maximum and minimum principal stresses, or you can call it as major and minor principal stresses. Next, let us measure the maximum and minimum shear stresses. So if I just check out the maximum shear stress, I can measure it here itself. Right, so that is somewhere around 36 MPa, 36 MPa because it is 36 mm. So it is 36. Now let me measure the angles 2 theta s1 and 2 theta s2. 2 theta s1 with respect to the reference plane, 2 theta s1 with respect to the reference plane. Okay, if I just check out 2 theta s1 with respect to the reference plane, it is giving me once again 136 degrees. 136 degrees. This is clockwise direction, so it is positive. And if I just check the other one, 136, and if I check the other one, it is giving me how much? 45, right? 45 and 136. So 136 is positive, 45 is negative, and this is 37 mm, right? So once again, let me check out. Yes, perfect. It is 37 mm. So let us go for the calculation. Okay, so here tau max comma tau min, some people call it as tau 1 comma 2, so that is plus or minus 37 MPa. Why? Because the measured distance is 37 mm and our scale is 1 mm is equal to 1 MPa, right? Now theta s1, so 2 theta s1 is 136 degrees positive, because whenever I say positive, same clockwise with respect to reference plane. I need not write it here once again. So theta s1 is equal to how much? 2 6 are 12, 2 8 are 16, so it is 60 degrees, sorry, 68 degrees. Similarly 2 theta s2 is 45 degrees, but that 45 degrees is measured, in anti-clockwise direction with respect to the reference plane. That is the reason it is negative. Therefore theta s2 is 22.5 degrees with a negative sign, right? So these are the maximum principal, minimum principal stress, their orientations, maximum and minimum shear stress, their orientations. Now we'll go for the shear stress and the normal stress on the oblique plane. Okay, so let me measure this. So this distance is 33 mm, and this distance here it is 64 mm, 33 mm and 64 mm. So sigma n is equal to 64 mm. 64 mm. Now tau value is 33 mm. So therefore tau is equal to 33 MPa. 33 MPa. If you just look at the diagram, tau comes in negative side. That is the reason I'll take it as minus 33 MPa. You can also take a minus sign here. It is minus 33 mm because it is coming below the origin. Right? This is also negative. So it is minus 64, and here also you are getting minus 64 MPa. I am either writing it as minus or I'll mention it as compressive. Both are one and same. Right? So these are the things which have been asked in the problem. At times he will also ask you to calculate the resultant and the obliquity. Right? Those two things also I will show it here. Then we'll wind up the problem. So let me proceed for calculating resultant and obliquity. So these are nothing but stresses on oblique plane. Stresses on oblique plane. Right? So these are the stresses on oblique plane. So let me proceed for calculating resultant and angle of obliquity. So what is obliquity, I'll tell you, and I'll also show you what is the resultant. So in order to calculate the resultant, first let me mark the resultant. Now I will show you where and which particular phase or which particular line is going to indicate the resultant here. So I am going to denote it here from this origin point O to this oblique plane F. From this origin point O to this oblique plane F. So this I call it as resultant. This I call it as a resultant. This I call it as a resultant R. Resultant R. Right? Now also there is something called as obliquity. So what is obliquity? Obliquity is the angle between resultant and the normal stress axis. Okay, this angle I call it as beta. This angle I call it as beta. So beta is called as angle of obliquity. So first let me measure what is the resultant, then I will measure what is beta. Right? So if I just go on for measuring the resultant, I am getting the resultant value as 74. Resultant value as 74 mm, and this value of beta, if I just check it, value of beta is around 27 degrees. Right? Now, so this is 74 and this is 27. Okay. So resultant R is measured as 74 mm. So therefore R is equal to 74 MPa. 74 MPa. Okay, R is 74 mm and it is 74 MPa. Right? So this is according to my graphical method. So just to confirm, by analytical method we know that we have solved it in the problem. R is given by sigma n square plus tau square. So if I do that, sigma n square plus tau square, this is by analytical method. Just for confirming things, you need not do this in your examination. Sigma n square is 64 square plus tau square is 33 square. So if I just check it out, I will be getting it as how much? 64 square plus 33 square, square root of this is 72.006, 72.006 MPa. Right, so this is the accurate value according to the analytical method. Since we are using graphical method, 1 or 2 MPa, right, so variations will be there and it will be permitted, right, it will be accepted in your examinations. Now similarly, obliquity, or it is also called as angle of obliquity is given by beta. So beta is 27 degrees according to the measurement whatever I have done. So same obliquity beta is measured using analytical method by using the formula tan inverse tau divided by sigma n. So therefore beta happens to be tan inverse, tau is how much, 33 with a negative sign, so this is minus 64, right. So therefore beta, if you just check it out, I am getting minus and minus are going to cancel, 33 divided by 64, shift of tan inverse of answer, so it is 27.27 degrees, 27.27 degrees, right. So this is 27.27 degrees. So this is perfect answer using analytical method, and this is our answer using the graphical method, right. So that's it. I hope things are clear. We'll wind up today's session. Have a good day. Take care. Bye bye.